Hi everyone, today we are going to talk about complex numbers. So before we talk about complex numbers, I want to do just a quick overview of the different types of real numbers. So we have natural, which is what we would call like counting numbers. So we start at 1 and then it's just whole numbers from there. Whole numbers is the next circle here. It's essentially natural numbers including 0. So 0, 1, 2, 3, 4. Integers would be the next range of numbers. So that includes what looks like all of the natural numbers, but also the negatives. So any non-fraction, non-decimal number, positive or negative or 0. Rational encompasses all of the numbers that are still real, but anything that can be written as a fraction. So you could tell if it's actually a fraction, if it's a decimal that ends, or if it's a decimal with a repetition. You can actually write any repeating decimal as a fraction. And then outside of that realm, you can see we have irrational numbers, which are still real numbers, but they're essentially decimals that go on forever, something like pi or root 2. So these are the types of real numbers. And then today we're going to be talking about complex numbers, which also brings in that idea of imaginary numbers. So an imaginary number, by definition, is defined as the square root of -1. So we know that really there's no such thing as the square root of a negative number, but in math we will still work with these types of numbers and we will call them I, and again that's an imaginary number. So I is just the square root of -1. So complex numbers are numbers in this form, a plus bi, and we call A the real portion and B the imaginary portion. So it's very possible to have no imaginary portion and just have a real portion. We could still call that a complex number, or just have an imaginary portion. The real portion could be 0 or not exist, and we could still classify it as a complex number. But they are written in the form of A plus bi. So when we're simplifying powers of I, you really only need to know the first 4 powers, and then we can simplify everything from there because this pattern just starts repeating itself. So anytime you see I to the first power, that's just I. Now I squared, we define I squared as -1, because remember I is square root of -1. So if we said, okay, the square root of -1 times the square root of -1, square root of -1. So we call I squared -1. So anytime you see I squared left in your expression, we're going to simplify it to -1. Now I cubed, we can simplify to -I, because I cubed is just I times I squared. So it's just I times -1, which gives us -I. And then I to the 4th, by definition, is equal to +1. Think of it as I squared times I squared. -1 times -1 is +1. So the powers of I will always simplify in this way, and it will repeat the same pattern. It will be I, -1, -I, 1. I, -1, -I, 1. So whenever you're simplifying a larger power of I, you're first going to want to divide out as many powers of I to the 4th as you can, because that's just equal to 1. And then from there, you can simplify what you have left over. So if you look at I to the 25th, well, we could rewrite this as I to the 4th to the 6th, which is I to the 24th, and then we just have another power of 1. We know I to the 4th is equal to 1, so this whole thing simplifies to 1, and we're just left with I, which we will always just leave as I. Now if you look at this next one, I to the 18th, we could write this as I to the 4th to the 4th, which gives us I to the 16th, times I squared. So again, this portion just simplifies to 1, so we're left with I squared, which we should always say is equal to -1. For I to the 12th, we have I to the 4th cubed, and that's the entire thing, so this would just simplify to +1. So essentially, if the power is a multiple of 4, it will simplify to 1. And then for this one, I to the 43rd, we can say is I to the 4th to the 10th. So it's I to the 40th, and then we still have I cubed left over. So again, this simplifies to just 1. So we're left with just I cubed, and I cubed is equal to -1. So anytime we have higher powers of I, we're always going to simplify them as much as we can. It will either be I, -1, -I, or 1. So the next thing we're going to do is we're going to do some basic operations with complex numbers. So really when you're adding, subtracting, or multiplying with complex numbers, you perform the operation just like you would with any other normal variable. So I treat it like a normal variable, and then just remember to simplify your powers of I like we did in the last slide. Sorry, my formatting got a little bit mixed up here. So here's part A and this is part B. So let's do part A together. Here we are multiplying two complex numbers. So we just start doing FOIL. So we have -6, and then here we have -4i minus 12i. So that gives us -16i. And then here, this gives us -8i squared. And then we're always going to simplify any larger powers of I. So the important thing to simplify here is I squared, which remember is always equal to -1. So we have -6 minus 16i. This actually becomes +8. So this leaves us with 2 minus 16i. And we're going to always write our final answer in the form of A plus BI. So we'll write the real part first and the imaginary part second. Okay, then let's do part B. So again, this is part B. So we're just adding some complex numbers. So first thing we can do is we can actually get rid of the parentheses, and then we'll just combine like terms. Remembering here to distribute that negative. So it's just 8 minus 2i minus 3 minus 5i, and then -7 plus 4i. And then here it's just combining like terms. So this leaves us with -2 because we have 8 minus 3 minus 7. And then here we have -7i plus 4i, so -3i. So really when we're adding or subtracting, it's just combining like terms. All right, so at this point I'm going to ask you to pause the video and see if you can simplify this expression. We'll check your answer in just a few seconds. Okay, so go ahead and check your work here. This you just need to be careful that you're following order of operations and you're just taking your time because it's easy to make a small mistake. Just remember that 2 minus I squared means 2 minus I times 2 minus I, so I multiplied this out first. And also remember that 4I squared is just -4. And then I multiplied these two binomials out next, leaving me with this. And remember here, this -12I squared will just become +12. And then here I factored out as many, or I separated as many powers of I to the 4th as I can, leaving me with just I squared, which this simplifies to +1, this simplifies to -1, which is how -3 turned into +3. And then the -15 canceled out with the +15 here, leaving me with just -29i. Okay, the last thing we're going to talk about today is what are called complex conjugates. So A plus BI and A minus BI are what we call complex conjugates. You might remember conjugate when you were learning about radicals. So for example, if you have the term 1 plus root 5, the conjugate of that would be 1 minus root 5. If you have maybe -2 plus root 3, the conjugate would be -2 minus root 3. So for a conjugate, the only thing that changes is the sign of your second term, which you can see is what's happening here. So the nice thing about complex conjugates is when you multiply by a complex conjugate, it eliminates the imaginary portion of your expression. So we're going to use this to help us simplify any expressions that have imaginary numbers in our denominator because we do need to rationalize. We can't technically leave any radicals in our denominator, and remember, I is technically a radical. Okay, so here we're going to simplify these two expressions by clearing I from our denominators, so we're rationalizing. So for this first one, again, we don't want I in our denominator because technically it's a radical. So we can actually fix this one just by simply multiplying the numerator and denominator by I. So that leaves us as 12I plus I squared over I squared. So remember, this just becomes -1. This also becomes -1. So that leaves us with -1 plus 12I divided by negative 1, which is just 1 minus 12i. And now this is simplified. Now for part B over here, we need to multiply by the complex conjugate to help us. And we're only going to multiply by the complex conjugate of the denominator. So we're going to multiply the numerator and denominator by 4 minus I, which is the complex conjugate. So in the numerator, we need to multiply that out. We're left with 20, and then here we have minus 5i minus 12i, so that's minus 17i, and then we have plus 3i squared. We'll simplify that in just a moment. And then in our denominator, you'll see what happens when we multiply by that complex conjugate. Here we have 16, and then we have minus 4i plus 4i, so that cancels out. And then we just have minus I squared, which we will simplify. So again, this becomes negative 3, because 3 times negative 1. So we have 17 minus 17i. And then in our denominator, this becomes minus negative 1, so really plus 1. So we can say over 17. So it is rationalized now, but we can actually simplify this a little more. We can call this just 1 minus I. And we are all done. Okay, here's the last example, so please pause the video and simplify this expression, and we'll check our answers in just a few seconds. All right, so go ahead and check your work here. Here you have to multiply the numerator and denominator by 1 plus 2i, and once you're done simplifying, you should end up with just 1 plus 2i. Kind of a coincidence that it happens to be your solution is the complex conjugate. That is your final simplified answer. All right, that's all for today's video. Thank you guys for watching.